I am an engineer, so there'll be lots of charts and tables, and I hope you get something out of it and I don't bore you to death. I am Matthew Parish with the Vicksburg District. I work in water management and water quality. And Dan had asked me to come speak about some of the dynamics, some of the changes in water levels we've seen through the last year that could affect our fisheries in these oxbows. And so I'm going to put in a brief plug about the Vicksburg District, and then I'm going to talk about some facts about the Mississippi River Basin. I'm going to go through some of the events we've had over the last 7 years. There's been some major events and some historical events. And then I'm going to talk a little bit about some climatic factors. So, Vicksburg District. Back. Part of the Mississippi Valley Division. The Mississippi Valley Division, 6 districts along the main stem Mississippi River. The Vicksburg District is a little over 68,000 square miles. We cover 3 states, Arkansas, Louisiana, and Mississippi. And we have approximately 300 miles of Mississippi River channel through our district. We have 12 locks, 9 dams, 10 flood control reservoirs, 3 hydroelectric power plants, 1,960 miles of levee, 478 flood control structures, 21 pumping plants, and 1,252 miles of navigable channel. The Mississippi River Basin, a drainage area of over 1,245,000 square miles. It drains all or parts of 31 states and 2 Canadian provinces. 41% of the continental United States is drained through the Mississippi River Basin. It is 2,350 miles long from the headwaters at Lake Itasca down to the Gulf of Mexico. The average discharge at the Gulf of Mexico is 600,000 cubic feet per second, and it takes approximately 90 days for water to travel from the headwaters down to the Gulf of Mexico. So little facts. If anybody asks you today how long it takes for water to travel from the headwaters down, you'll be able to tell them. So we're going to start with 2008 and work our way back to today. And the lots of historical events that have happened over the last 7 years. So this is a plot of Arkansas City, and all the plots are similar. So to go over briefly, the top blue line on these plots is the historical daily maximum. Don't look at the dates on this plot. I noticed last night they were different than the others. But typically, we look at 1941 to present, since 1941 was about when the cutoffs were completed on the Mississippi River. The red line is the actual observed stages for that year. The black line is the average daily stage for that station. And the green line right here is the daily minimum observed stage. So 2008, and these lines across here will represent bank full, phase 1, phase 2. We're pretty much going to be covering Arkansas City and Greenville, so they'll say the same. 2008, big flood year, lots of high water, set new daily maximums for the period of 1941 through 2008 at many stations. Arkansas City, as I apologize, this was 1932 data included, but you see we set later on in the year a new daily maximum at the end of the year. Different from the historical pattern, but we set a new daily maximum late in the year. Greenville, for the period 1941 to 2008, pretty much the 2008 floods set lots of new high water records, daily records. Of course, the peak in 2008, and then as it went down throughout the year, you set several other new daily maximums. So it was definitely a lot higher than what you would average to see at Greenville any given year. Of course, the only way to follow up a big flood is by another big flood. Well, I'm sorry, we'll talk about what caused the 2008 flood. The precipitation, this is percent above normal. And as you can see, the red, the Arkansas, Missouri, Upper Miss, and the Ohio and Tennessee basins received anywhere from 150 to, in some areas, probably 400% above normal precipitation for the month of April. That's above what they're supposed to get. In the month of May, pretty much the Upper Miss received above average rainfall in the area of 150 to 300% of normal. So you had lots of rain falling in the basins above Vicksburg district. We had some high water. So we followed 2008 up with 2011, the big one. Arkansas City, of course, as with many other stations on the Mississippi River, set some historic highs. Of course, there at the peak, and then at Greenville also at the peak. So lots of high water. That's the one everybody remembers because it's the most recent, but also the largest of our lifetime. Rainfall that attributed and caused the 2011, the percent of normal once again. You have some high rainfall events. You're looking at anywhere from 200 to, I think the pink's about 400 to 500% of normal through the Ohio and the Upper Miss Basin. And then in May, you see some more above average precipitation levels, anywhere in the neighborhood of 150 to 200% in the Arkansas River and Missouri River basins. So a lot of, on top of the snowpack, record snowpack, but all the right factors came together to produce the major event. So we follow up the flood of record with some extreme low water. This is an image borrowed from NASA that shows some sandbars that were exposed near Tunica. Now, when the water levels get low here, it affects navigation, that some barges may have to wait to pass through some binways once some other barges pass. But up around St. Louis, they were having to blast and grind and blow rock formations that were at the bottom of the river. They were having to release water from flood control reservoirs and navigation reservoirs up in the upper districts so that they would have enough water at the locks so barges and tows could make their way up and down. It was a big effort on lots of people's parts to keep navigation open in some portions of the river. So record flood to record lows. And I'm going to show you some of these record lows. At Arkansas City, this is a dual plot for 2012 and 2013. As you can see, the start of the year, a little above average, a little below, but then we just dive and stay below average. And as you can see, we set new daily minimums for sometimes in July and August, September, October, and even on into December. And the same pattern at Greenville. July through December, low water. And I believe it affected some of the grain shipments around here. Some of the terminals were having difficulty getting barges in and out. They weren't able to load their barges as much as they usually would. So it was quite a problem. And the rainfall event that sort of led us to this point, from record high to record low, was a nationwide drought. This is a water year which runs from October to October, so October of 2011 to October of 2012. you see pretty much the majority of the United States is yellow, which is pretty much somewhere between 50 to 90% below normal precipitation. So when upstream doesn't get the water, our water levels are affected. And then we have the 2015 flood, which wasn't a big flood for Mississippi River standards. We had a big flood on the Red, which this is a picture of the Red, because I wanted to use actual photos for flooding events of the time period. This is on the Red at Shreveport. If you've ever been to Shreveport, not this day, but at the peak of the flood, you could try out your new bass tackle from the front door of the Bass Pro Shops. You didn't have to leave the parking lot. But 2015 was an interesting flood on the Mississippi, not because of the elevations, as we saw in 2008 and 2011, but due to the time of year. I'm going to show you Cairo this time, because Cairo, it was a interesting year. They started pretty close to a daily minimum near March. Got above bank full, had a little dual peak, came back down. And then on in June and July, they were setting daily maximums for a little over a month. We translate that down to Arkansas City and see the same new daily maximums. From middle of July to the 1st of August, new daily maximums. As I said, not a big flood, just really hit flood stage at Arkansas City. But for this time period, it is a record setter. Greenville, we had our same pattern, a little below average, a little above average. The rains from up in the upper part of the basin came, and Greenville went above flood stage and set new maximums for pretty much July, 1st of July through the 1st of August. So what weather events do we see to cause these events? Well, this is a monthly observed precipitation for the month of June. And as you can see, the Midwest, Ohio, Tennessee basins received anywhere from 6 to 15 inches of rainfall. On a percent basis, that's anywhere from 150 to maybe 400% of normal rainfall. They received above that. Percent of normal for July, as you can see, the Tennessee basin and middle Mississippi, St. Louis and that area, received anywhere from 150 to 200 to 300% of what they typically receive. A lot of y'all probably know Mr. Waylon Hill. He was the forecaster and operator and water technician in water control for years. Operated our flood control projects and forecast the Mississippi River. And as Mr. Waylon would put it, whatever falls up there has to pass through here. So our water levels here are greatly dependent upon whatever they receive in the upper Miss, the Missouri, the Arkansas, and specifically the Ohio. Most of our water is going to come through the Ohio basin. So it just goes back to the water cycle, like it was taught in high school and junior high and elementary. Your evaporation, transpiration, precipitation, snowfall. Of course, snow water is different than rainfall. Typically, snow melt or snow water contains, for every 6 to 10 inches of snow, you'll have 1 inch of runoff versus 1 inch of, you have less water content in your snow. You're going to have some that's going to infiltrate into the groundwater, some that's going to be stored in storage areas, and then you have other water that's going to run off. And that runoff that goes down into the rivers is what we're going to see down here in our district. So what are some climatic factors that can impact how much water, how much rainfall, precipitation they receive up north that can affect our river levels here, to whether we see our high stages or our low stages? We currently have one going on right now with an El Nino, and this happens pretty regularly, but a typical wintertime El Nino pattern causes us to receive a little bit more precipitation down here, not as much in the upper parts of the basin. They're a little drier, So typically, they're not seeing as much water. We're not going to see it down here. Then, of course, you have your La Nina effects, where they receive a little bit more moisture in the Ohio Basin and the Upper Miss Basin, and we're a little drier down here. But then, what about climate change? According to, I think this is climate.gov or some government publication, with the high emission standards, I don't know what their high emission standard model is, but they forecast with higher emissions that in the winter, spring, and some of the fall, the upper portions of the Mississippi River Basin and Ohio River Basins could see more precipitation. Higher precipitation is probably going to lead to higher runoff and maybe some higher river levels than what we're typically used to here. However, if you go on what they've observed in the precipitation change, we're already receiving higher precipitations, higher precipitation levels, not just on the Upper Miss and the Ohio basins, but also here in the southeast. So these are all predictions, models. Specifically zeroing in on the southeast, that's the percent change by decade. Pretty much they have 60s, 70s, 80s, 90s, 2000s all being a wetter than normal period for us, a change in the more rainfall direction. And this is something that's important, is the observed change in heavy precipitation. The faster and harder precipitation falls, the more runoff that occurs. The more runoff, the higher the stages, the higher the river levels. And observed over the period of record that they were looking at, 27% higher heavy precipitation events in the southeast, 37% in the Midwest and part of the Ohio Basin, 16% in the Missouri and Arkansas basins. So if that factor of climate change, more heavy precipitation events, that could lead to some higher stages at some different periods of time, like maybe we saw this year. So, all right, I've put all this out there basically to say three things. It's a dynamic system. We can have highs and lows at times, even when we don't expect it. The stages and flows on the lower Mississippi depend upon what falls upstream and the upstream runoff. And there's a number of climatic factors that can change and contribute to our stages and flows. So, does that hold the questions? Hope I didn't bore you too bad.